Welcome to The Explainer. Today, we're diving deep into something truly fundamental, something that feels almost magical about our own intelligence. It's this ability we have to understand and create brand new ideas just from familiar old building blocks. It's a power we use every single second, but it's one that has been surprisingly hard to pin down. You know, the linguist Noam Chomsky nailed it way back in 1956, the infinite use of finite means. Just think about that. We have a limited set of words, a finite number of rules, but with them, we can generate a practically infinite number of sentences. We can express thoughts no one has ever had before. This isn't just some cool party trick. It's the absolute core of how we think. So let's get right to the heart of it. How do our minds actually pull this off? How can you understand something you've never, ever encountered before? It feels so effortless to us, but for scientists, this is one of the biggest walls standing between us and a truly human-like AI. Here's a perfect, simple example. You've seen cows, right? Probably in a field. And you've seen beaches. But even if you've never seen those two things together, I bet you can instantly picture a cow on a beach. Your mind just does it. It seamlessly combines the cow part and the beach part, and poof, a new scene is born. This incredible ability, it has a name, compositionality. It's the hallmark of human intelligence. But for AI, it's a massive challenge. See, an AI trained on thousands of pictures of cows in fields and beaches might be completely thrown by a cow on a beach. It hasn't seen that exact combo before. So cracking compositionality, that could be the key to unlocking the next level of intelligent machines. All right, so if we're going to solve this problem, we first have to define it. And that brings us to the first major hurdle. Our common sense idea of what compositionality is, well, it feels right, but it turns out it's just not good enough for building things. On the surface, the definition seems pretty simple, right? The meaning of a sentence is just the sum of its parts, all put together in a certain order. The cat sat on the mat means what it does because of the words cat, sat, on, and so on, and the way they're structured. Makes total sense. Well, it seems simple until you actually try to build a machine based on that definition. The minute that computer scientists and neuroscientists tried to make this idea concrete and formal, they realized it was full of holes. It was like trying to build a skyscraper on a foundation of, well, sand. So let's look at the 4 big cracks in this old foundation. First off, what even are the parts of a thought inside a brain or an AI? It's not like you find little word-shaped neurons in there. Second, what's the structure? A sentence has grammar, but what's the grammar of a mental image? Third, that phrase determined by is just way too loose. I mean, under that definition, a system that just memorizes idioms, like he kicked the bucket, would count as compositional. But that's just rote memorization, not a flexible system. And finally, the old definition is a yes or no question. It's either compositional or it isn't. But shouldn't it be more of a spectrum? So all these problems show we need something better, something much more rigorous. And that brings us to the real breakthrough at the heart of this explainer. A brand new theory that completely reframes the problem, using a powerful idea from computer science, compression. The central idea is something called Kolmogorov complexity. Okay, sounds intimidating, but the intuition is actually beautiful. The complexity of anything, a sentence, an image, even a thought, is just the length of the shortest possible recipe to create it. Think about it. A random jumble of letters is really complex because the only recipe is write down this whole jumble. But a pattern, like A, B, A, B, A, B, is simple. The recipe is tiny. Repeat A, B 3 times. Simple things are super compressible. So what this new theory says is that compositionality isn't about those vague parts and structures from before. Instead, it's a trade-off. It's a ratio between 2 things. The need to express a whole lot of different ideas, that's expressivity, and the need to do it with a really simple set of rules. That's simplicity, or what we're calling compressibility. And boom, this leads to the aha moment, a real formal definition. Now I know, it looks like math, but hang with me because the idea is actually very elegant. It says compositionality is just a ratio. How much information can a system hold divided by how simple the rulebook is for building that information? Let's walk through it. Let's decode this thing. So Z is just the complex idea we're trying to measure, like our cow on a beach. The top of the fraction, K's of Z, measures how much information is packed into that final idea. But the bottom part, that's the magic. It measures the complexity of the rules you need to combine the parts. Think of it like the size of the instruction manual needed to get from cow and beach to the full picture. A smaller, simpler instruction manual means a more compositional system. And this illustrates the difference perfectly. A highly compositional system, like human language, has a small, elegant instruction manual. The rules are simple. That means the bottom of our formula is a small number, which makes the final score high. But a non-compositional system, like just memorizing a bunch of idioms, is like having a giant lookup table. The instruction manual is enormous, which makes the final score really, really low. Okay, so that's the theory. It's elegant, it's mathematical, but the real question is, does it actually work in practice? So let's move on and see what happened when this new definition was really put to the test. First, the researchers tested it on synthetic data, where they knew exactly what the answer should be. They created these representations from sentences of different lengths, and just as they hoped, the metric correctly found that as the sentences got longer, which means more parts were being combined, the system's compositionality score went up. That fits our intuition perfectly. Next, they played with how much a word's meaning depended on its context. When the words acted like simple, independent Lego bricks, the metric gave a high score. But as the meaning of a word started to depend more and more on the words around it, kind of like an idiom, the score correctly went down. The system was less compositional. Again, the theory worked exactly as it should. But the ultimate test is on real languages, right? First, they aimed this new tool at languages created by communicating AIs. And amazingly, it correctly figured out which groups of AIs had developed more structured, more compositional languages. Then, they turned it on us, on human languages like English, French, and Japanese. The result? They all scored similarly high, which actually backs up a huge theory in linguistics that all human languages are at their core equally powerful and compositional. So this is way more than just an academic exercise. Having a real mathematical ruler to measure compositionality, well, it has some pretty profound implications for the future of AI. For the very first time, we can stop just going with our gut feelings. We have a single quantitative score to measure one of the absolute pillars of intelligence. And you know what they say, you can't improve what you can't measure. Well, now we can measure this. So why does this matter to you? Well, first, we can finally score AI models on how compositionally they think. This could be our best shot yet at creating AIs that can truly generalize, that can handle new situations and learn way more efficiently from much less data. And most importantly, it gives us a North Star, a guiding principle to help design the entire next generation of AI architectures. Which leaves us with one last, pretty mind-bending thought. If compositionality, the very engine of our flexible thinking, is fundamentally about expressing complex ideas with simple, compressible rules, what does that imply about human creativity? Is a brilliant new idea just the most elegant and simple compression of old ones? That's definitely something to chew on.